Hello everyone, and welcome to this video. There's going to be an introduction on decimals. Now, a decimal is a way of writing a number that is between integers. And I've got some examples here in red of ones that you could have. So we've got 0.5 exactly in between 0 and 1. Here we've got 0.3333333. Now, I feel like you've definitely seen decimals before. So this video is more just refining your knowledge, making sure it's very mathematical and that we know the correct terminology. Now, when it comes to decimals, there are three types of decimals. We've got terminating decimals, recurring decimals, and irrational numbers. Now, this unit itself only looks at terminating decimals, but I think it's important that you are aware of the other types as well. So a terminating decimal is one that has a finite number of digits after the decimal point. So for example, 0.5, 0.62, 0.1674, so it's got a specific number of digits after the decimal point. Now a terminating decimal is a fraction with a denominator that's either a 10, 100, 1,000, 10,000, so on. Now, as I said, this unit we're mostly going to be focusing on terminating decimals. But you can also have recurring decimals. So a recurring decimal has an infinite number of digits after the decimal point that makes a pattern. So 0.33333333 that goes on forever, I'm sure you've seen before. But we could also have other patterns like 0.151515 there. It's a repeating 15, it goes on forever. We could have a specific set of digits and then a number or then a pattern that repeats forever. Those would be recurring decimals, which you will see later on in phase 1. An irrational number, which we're not really going to be doing any irrational numbers until phase 2 when you see pi or when we get into higher GCSE and you look at surds, but an irrational number is a type of decimal that does not terminate and does not repeat. So you have an infinite number of digits that goes on forever. There's no pattern to it, no sequence at all. It just goes on forever. You can't actually write down that number exactly as a decimal. If you try to, you would just be writing forever. Now, let's understand the way that this place value works. So, we're definitely familiar with units, tens. I could also have hundreds, thousands, 10,000s, and so on. After the decimal point, we've got tenths, which, as I said before, is literally the fraction a tenth. How many tenths do we have? We've got hundredths, which, again, is the fraction 1 over 100. We've got thousands, which is 1 over 1,000. I could have 10,000s, 100,000s. Again, that goes on forever. So if I was going to write down the decimal 0.3, that means I've got 3 tenths. 0.3 is 3 tenths. That's what it is. Similarly, 0.23, here I've got 2 tenths and I've got 3 hundredths. I've got altogether 23 hundredths. I could have 0.07, which would be here 7 hundredths. Decimals, terminating decimals, are just fractions where the denominator is either 10, 100, thousands, 10,000s, and so on. One thing that you have to be very careful with is here, this is 0.23 for 23 hundredths. You do not say 23 because that is not what this place value is. After the decimal point, you just say the digits. So this would be 0.23 for 23 hundredths. This would be 0.07 for 7 hundredths. You would have 0.479 for 479 thousandths. You just read the digits after the decimal point. Something else that I need you to be very aware of with this place value. Similarly, if I have, I don't know, the number 1,714, if I wrote some zeros over to the left, these are called preceding zeros, these don't change the value of the number. This is still 1,714. Similarly, with decimal places, if I add zeros here, that doesn't change the value of this. Here, 0.30 is just 30 hundredths, which simplifies down to 3 tenths, as I'm sure you remember from simplifying fractions. That's worth exactly the same. That's worth exactly the same as 300 thousandths. That is still 3 tenths. So adding zeros afterwards doesn't change the value of the number when it's after the decimal point. Now all of these numbers I've done have all been between 0 and 1. You can still have decimals that are bigger than that. I could have 3.1. I could have 17.68. It doesn't matter. Again, adding zeros after decimal point, that would still be worth exactly the same. That is worth exactly the same. That is still worth exactly the same. So, here, last thing we're going to look at is just how this appears on a number line. So, here, let's start with a normal number line. I've got my integers here from 0 to 10. Let's zoom in on between 7 and 8. So between 7 and 8, I could have 10 little spaces in between here. And what are those numbers that go between 7 and 8? So remember, 7 is exactly the same as just 7.0, and 8 is exactly the same as 8.0. That's going to make it easier for me to see that these numbers between it are going to be 7.1, 7.2, 7.3, 7.4, and so on. Now, again, let's zoom in again. What are these numbers between 7.2 and 7.3 if I was to zoom in on that section? Remember, 7.2 is exactly the same as 7.20. 7.3 is exactly the same as 7.30. So these numbers between it are going to be 7.21, 7.22, 7.23, 7.24, and so on. Again, I can zoom in. What are these numbers between 7.25 and 7.26? 7.251, 7.252, 7.253. Again, I can keep zooming in. You can always zoom in. What's these numbers between 7.257 and 7.258? Again, 7.2571, 7.2572. There is an infinite amount of decimal numbers. Any two numbers you give me, I can always write a decimal in between them. Always. Always. That's why decimals are so powerful. That's why they're so useful. Fractions are difficult to do maths with. They're difficult to compare sizes with. That's why decimals were invented. Because it's a much easier way of representing these numbers and much easier to do maths with them. Now, most important thing I want you to take out of this video is this idea that the zeros afterwards don't change the value of the number when it is after the decimal point. So 7.20 is exactly the same as 7.2. 7.310 is exactly the same as 7.31. 7.800 is exactly the same as 7.8. Thank you.